This lectures cover the measures of regression and prediction interval. In section 9.1, we learn how to find the PSC correlation coefficient. Section 9.2, we learn how to find the regression line or the regression equation. In these sections, we're going to learn how to again interpret the three types of valuation by the regression line. And also we're going to learn how to find and also interpret the coefficient of determination. Normally, coefficient of determination is represented as R squared. So if we know the R value, we square it, and that will give us coefficient of determination. And also we are going to learn about standard error of the estimate for a regression line. So the three types of variation about the regression line. First, we have the total variation, explained variation, and unexplained variation. Now, to find the total variation, we need to first calculate the total deviation, explained deviation, and unexplained deviation. So to find the total deviation, it will be the difference of Y value minus the mean. Explained deviation will be the difference of the Y predicted value or Y carat minus the mean. Then unexplained deviation will be Y or the observed Y minus the predicted Y. Now, total variation will give us the sum of the squares of the differences between the Y value of each other pair and also the mean of the Y. So the formula will be the sum of the difference of Y minus Y mean all square. So if we have a sample data of 10, it means we are going to find the mean of that 10 values. Then we find the difference of each value with the mean, and we square it, then we sum all. And that will give us again the total variation. Now to find the explained variation, it will be the sum of the squares of the difference between predicted Y value and also the mean of the Y. Next, we find the unexplained variation, which again will be the sum of the squares of the differences between the Y value of each other pair and each corresponding predicted Y value. So now the sum of the explained and unexplained variation is equal to the total variation. So total variation will give us explained variation plus unexplained variation. Next, the coefficient of determination, again, is the R square. So R square equal to explained variation divided by total variation. Or sometimes if we know the value of R, then we square it. Now let's go through this example and we are going to explain all the terms. So here we have a question saying that the correlation coefficient for advertising expenses and company sales. In section 9.1, we learn how to again find the correlation coefficient between two values given to it. The advertising expenses will be our independent variable, and the company sales was our dependent variable. So we're able to find the R value, and the R value is 0.913. Now we are going to find the coefficient of determination, and we are going to explain what the value means. So to find that, we need to square R. And when we square 9.913, we get 0.834. So this means 83.4% the variation in the company sales can be explained by the variation in advertising expenditures, which means when we subtract 83.4 from 100, we have roughly about 16.9% of the variation is unexplained. Now, standard error of estimate, we say this is the standard deviation, the observed Y values about the predicted Y value for a given X value. So the formula is the square root of the sum of the difference of each Y value and the predicted all square divided by N minus 2. Again, N will be the size of the sum. So the closer the observed Y value are to the predicted value, then the smaller standard error of estimated. Yeah. So let's follow the steps here in words and also in symbols, how to get the standard error of estimate. So first we make a table that include the column headings. So this column headings will be X, Y carat, difference of Y, the Y carat, and also difference of Y carat or square. Then we are going to use the regression equation to calculate the predicted Y values. Then after that, we calculate the sum of the squares of the difference between each observed Y value and the corresponding predicted Y, which will be, again, the sum of Y I minus Y carat I squared. Then next, we can find the standard error of estimates, which again will be square root of the sum of the difference of the Y values and of the predicted Y value or square divided by N minus 2. So here, question is given to us how to estimate the standard error. A regression equation for advertising expenses and company sales data. It was calculated in section 9.2, and this is the equation. Y carat equal to 50.729x plus 104.061. Now they say we should find the standard error of estimate. So here we can use the table to calculate the sum of the square differences of each observed Y value and the corresponding predicted Y value. And this is the data set given to us in section 9.2. X represent the expenses, Y represent the company sales. So we were able to find using the equation, we were able to find the Y carat. Okay, the equation is what is here. Y carat equal to 50.729x plus 104.061. So we plug in the values and this is what we get. Now we find the difference of Y value and the Y carat and we square it and that's the answer here. 0.6561, 1.5129. Then the sum of it is what we have here. So 635.3463. And this will be unexplained variation. Then next we know the value of N, which is 8. We saw the difference unexplained variation or the difference of sum of Y, I minus Y carat I or square. So we can plug this in our formula for the standard error. And that will give us square root of 635.3463 divided by 8 minus 2. And that gives us roughly 10.29. So here we say the standard error of estimate of the company sales for a specific advertising expense is about $10.29. Now, next is the prediction intervals. We say that if we have two variables have a bivariant normal distribution. If for any face value of X, the corresponding values of Y are normally distributed. And for any face values of Y, the corresponding X values are normally distributed. This gives us bivariant normal distributions. So the prediction interval can be constructed for the true value of Y. So given a linear equation, Y carat equal to MS plus B and X, so a specific value of X, which is here C prediction interval for Y is Y carat minus E and Y carat plus E. So Y will be less than Y carat plus E or greater than Y carat minus E, where the E value will give us TC SE, which is again standard error, then 1 plus 1 over N plus N XO minus X bar all square divided by N times S square sum minus S square or sum. So here we say the point is Y carat and the margin of error is E. The probability that the prediction interval contains Y is again C. So how do we find this? To construct a predicted interval for Y for a specific value of X, first we need to find the degree of freedom. So identify the number of ordered pairs in the data set, which is N, and also the degree of freedom. So degree of freedom, N minus 2. Then we can use the regression equation and the given S value to find the point estimate, which is our Y caret. Then we can find the critical value TC using the table 5 in our appendix B that corresponds to the given level of confidence C. Then we find the standard error of estimate using the formula. Then we find the margin of error, again using the formula. Then find the left and right endpoint, which will be the difference of Y caret and E and the sum of the Y caret and E. And that will be our, again, interval. So a question is given here, we should construct a 95% prediction interval for the company sales when the advertising expenses are 2,100. What can you conclude? So this is a previous example in 9.2. You can recall the sample size is 8. We already have the regression equation, which is Y caret equal to 50.729x plus 104.061. We also find the standard error in the previous slice, which gave us 10.290. We know the sum of x, we know the x squared sum, and we know the x bar or the x mean. So we can find the point of estimate by using the question set 2,100, which is 2.1. By using the 2.1, because this is in 1,000. And that gives us, the prediction gives us 210.529. So here we go to the table. First, we find the critical value to be 6. Then we go to the table. We know the alpha, this is 95% prediction. So the alpha value will be, again, 0.05. So from there, we can find the TC from the table, which is the critical value. Then we find our E, margin of error. Here we are using the TC value, the SC we have, and plug in all the values. And that gave us 26.857. Then we have our left-hand point. That will be the difference of Y caret and E. Then right-hand point will be the sum of the Y caret and E. So that will be our answer here. So our interval, which is given here, will be between Y should be greater than Y83.735, and it should be less than 237.449. So here we can say that we are 95% confident that when advertising expenses are 2,100, the company sales will be between this value, between 183,735 and 237,449. So that will be the conclusion of these lectures. And again, see you in the next lectures. Thank you.